Hello, in this lecture we will find out the values of line segments X and Y. In the drawing we have square DEBF I'll repeat again. In the drawing we have square DEBF. The square is inside the right triangle, triangle ABC. One side of square DBEF is equal to 1 unit, so all of its sides are equal to 1 unit, and the square is inside the right triangle, triangle ABC, and the hypotenuse of the right triangle, triangle ABC, the hypotenuse AC equals to 3 units, and we want to find out the values of line segments FC that equals to X, and the value of line segment AD that equals to Y. Okay, so first of all, we know that the opposite sides of a square are equal to each other. That is to say, DE is equal to BF, DE is equal to BF, and BC is one side of the right triangle, triangle ABC. Therefore, it is absolutely a straight line. So BC is a straight line. And we know that BF is part of the straight line BC, and it is parallel to DE. And if part of a straight line is parallel to DE, then the straight line itself BC will be also parallel to DE. Therefore, BC is also parallel to DE. BC is parallel to DE. I will repeat again. BF, that is part of the straight line BC, is parallel to DE, and therefore the straight line itself BC will be also parallel to DE. So BC is parallel to DE, and we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. I write it down. Corresponding angles between parallel lines are equal to each other. I repeat on rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. And here those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other according to rule number 1. So can I know that angle AED, this angle, is equal to this angle, that is angle ECF, according to rule number 1. I will put again, angle AED equals to angle ECF according to rule number 1, because of the fact that those two corresponding angles are located between the parallel lines DE and BC, therefore they are equal to each other. And if we define angle AED, this angle is theta, then you can write here that angle AED equals to theta according to our definition. Then from this equation, theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta. Angle ECF equals to theta. So we can write here that angle ECF, this angle, also equals to theta. So we found out that those two angles, they are equal to each other and they are both equal to theta. In the next step, I will present to you a new rule that is actually rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, AB is one side of the right triangle, triangle ABC. Therefore, AB, it is absolutely a straight line. AB is a side of a triangle. It is a straight line. So if we focus on this side of the straight line AB at point D, we define angle ADE as X. So on this side of the straight line AB at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D at this side? We have here 90 degrees plus angle X, the sum of those two angles must be equal to 180 degrees. I write it down. X plus 90 degrees. In total, the sum of those two angles must be equal to 180 degrees according to this rule number 2. So here we will subtract 90 degrees from this equation and we will get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So I'll substitute angle X by a right angle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is a straight line. BC is a straight line. And we define angle EFC, this angle is angle Y. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of the straight line equals to 180 degrees. So here 90 degrees plus angle X must be equal to 180 degrees. Here we subtract 90 degrees from this equation and we get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle. We substitute angle X by a right angle. Therefore, triangle EFC is a right triangle. And also triangle ADC is a right triangle. So we'll focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, here tangent theta equals to AD over DE. I'll repeat again. In the right triangle, triangle ADC, tangent theta equals to AD over DE. Here AD equals to Y according to what is given us in the question. And DE equals to 1. It is one side of the square DEBF. So in conclusion, we found out that tangent theta in the right triangle ADC equals to y. In the next step, we will focus on the right triangle EFC. Here, tangent theta will be equal to EF over FC. I will repeat again. In the right triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 unit and FC equals to X according to what is given us in the question. So in the right triangle EFC, tangent theta equals to 1 over X. In conclusion, we found out that in the right triangle EFC, tangent theta equals to 1 over X. So here we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, so equation number 3 states that tangent theta according to equation number 1, that is actually equals to y, must be equal to tangent theta according to equation number 2, and according to equation number 2, tangent theta equals to 1 over x. So in conclusion, we found out that according to equation number 3, y equals to 1 over x. So here we will multiply equation number 3 by x, and we will get that y times x equals to 1. So what does this equation means? Whenever the multiplication of two numbers by each other is equal to 1, it means that 1 is the inverse number of the other. So we can write down that x is the inverse number of x is the inverse numbers of y, and it's also true to say that y is the inverse number of x. For example, 5 times 1 over 5 is equal to 1. Therefore 5 is the inverse number of 1 over 5, and 1 over 5 is the inverse number of 5. And we have also a rule that relates to inverse numbers. The rule is that each number has only one inverse number. Each number has only one inverse number, so the inverse number of 5 is 1 over 5 and only 1 over 5, and the inverse number of 1 over 5 is 5 and only 5. Okay? In the next step, we will focus on the right triangle ABC. Here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared. AC squared. Then the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BC squared. Okay, in the right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to AB squared plus BC squared. Here, we know that AC equals to 3 units. Therefore, AC squared is 3 squared. 3 squared is 9. Equals to AB squared. AB is equal to y plus 1, so AB squared is y plus 1 squared plus BC squared. BC is equal to x plus 1, so BC squared will be equal to x plus 1 squared. In conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here, we will open the brackets on this side of equation number 4, and we will get that y plus 1 squared is equal to y squared plus 2y plus 1 plus x plus 1 squared is equal to x plus 1 squared equals to x squared plus 2x plus 1, and in the other side of the equation we have 9, so it equals to 9. But according to equation number 3, we've already found out that y equals to 1 over x. So here we can substitute y in equation number 4 by we can substitute y in equation number 4 by 1 over x. Because y equals to 1 over x according to equation number 3, so we'll do it now, and we'll get that according to equation number 4, y squared, y is 1 over x, so y squared will be equal to 1 over x squared plus 2y. Y is 1 over x, so it is plus 2 times y over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we will organize the expression inside in equation number 4 in a different way. Here we write down that x squared plus y over x squared plus 1 plus 1 is 2 plus 2x plus 2 times 1 over x equals to 9. Here the expression inside the brackets x squared plus 1 over x plus 2 is equal to x plus 1 over x squared. And here we have 2x plus 2 times 1 over x, so we will take 2 as a common factor out of these two expressions. So 2 is a common factor. Inside the brackets we will have here x, and from this expression what is left, so we took from it 2 as a common factor, what is left it is actually 1 over x, that equals to 9. So here we have x plus 1 over x squared plus 2 times x plus 1 over x plus 1 over x equals to 9. So we define t as x plus 1 over x, that is to say t is equal to x plus 1 over x according to our definition. And then we can substitute x plus 1 over x in equation number 4 by t. We will do it now, and we will get that x plus 1 over x squared, it is actually equals to t squared plus 2 times x plus 1 over x, it is actually 2t plus 2t that equals to 9. Here we will subtract 9 from this quadratic equation, and we'll get that t squared plus 2t minus 9 equals to 0. So here we have a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. The formula is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a and b and c are the coefficient of the quadratic equation, and x is the variable that we are looking for. So in our specific quadratic equation, t squared plus 2t minus 9 equals to 0, the variable that we are looking for is t, so x equals to t, and the coefficients of this quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to minus 9. Okay, the only thing that is left to do here is to put the data inside the formula for x, and we will find out the value of t, the variable that we are looking for. So x equals to t, so here t equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b square. B is 2, so b square is 2 squared, 2 squared is 4, minus 4 times a times c. A is 1, c is 9. So minus 4 times minus 9 is plus 36, over 2 times a. A is 1, 2 times 1 is 2. So in conclusion, we found out that t equals to minus 2 plus minus square root of 4 plus 36 over 2. 4 plus 36 is 40. So we write down that t equals to minus 2 plus minus square root of 40 over 2. 40 is 4 times 10, and the square root of 4 is 2. So we can write that t equals to minus 2 plus minus 2 times square root of 10, okay, over 2. And so t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so we left only with square root of 10. So here we will have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10. And the second solution for t is t equals to minus 1 minus square root of 10. We will focus on the second solution. The second solution is t equals to minus 1 minus square root of 10. According to our definition, t equals to x plus 1 over x. We'll substitute t by x plus 1 over x, and it equals to minus 1 minus square root of 10 here x, it is actually length. X is the length of side FC of the right triangle FC, triangle EFC, the right triangle EFC. Therefore, x must be a positive number, and 1 over x must be also a positive number. So x plus 1 over x is a positive number. And in the other side of the equation here we have minus 1 minus square root of 10. Minus 1 minus square root of 10 is a negative number. And here we have a contradiction, because a positive number can never be equal to a negative number. And because of this contradiction, we will conclude that this solution for t, that t equals to minus 1 minus square root of 10 is incorrect solution, so we will cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. According to our definition, t equals to x plus 1 over x, and it equals to minus 1 plus square root of 10. Here we will multiply this side of the equation by x, and then we will divide it by x in order to have a common factor with 1 over x. So we get that x times x is x squared plus 1 over x equals to minus 1 plus square root of 10. Here we will multiply this equation by x, and we'll get that x squared plus 1 equals to square root of 10 minus 1 times x. Here it is allowable to multiply the equation by x because, as I already said, x is a positive number, it can never be 0, therefore it is allowable to multiply the equation by x. So we got here a quadratic equation, x squared plus 1 equals to square root of 10 minus 1 times x. Here we'll subtract from this equation square root of 10 minus 1 times x, and we'll get the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we have here a quadratic equation. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution for x is x equals to, the general solution for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay? So here we'll put the data inside the formula for x, and we'll find out the value of the values of x of this quadratic equation. Okay, so we'll get that x equals to minus b, b equals to minus square root of 10 minus 1, so minus is plus, so we get that minus b equals to square root of 10 minus 1 plus minus square root of b squared minus 4 times ac. B squared will be equal to square root of 10 minus 1 squared minus 4 times a times c. A is 1, so 4 times 1 is 4, and c is also 1, so in conclusion minus 4ac equals to minus 4 over 2a. A is 1, so 2a is 2 times 1 is 2. So here we have x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 square. We will calculate the value of this expression according to the formula that a minus b square equals to a square plus b square minus 2 times ab. Here a is equals to square root of 10 and b equals to 1. So a squared is square root of 10 squared is 10. Minus b plus b squared is plus 1. Minus 2 times a is square root of 10 and c is 1. So times 1. All divided by 2. Here 10 plus 1 is 11 and 11 minus 4 is 7. So we get here that x equals to square root of 10 minus 1 plus minus. Inside the root we have 11 minus 4 is 7 minus 2 times square root of 10, all divided by 2. Okay, so we found out that x equals to square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10. Here we will focus on the expression that is inside the root, that is actually 7 minus 2 times square root of 10. And we will change the form of this expression. We will represent it in another way. I repeat again. We will change the form of the expression that is inside the root, that is actually 7 minus 2 times 10. So 7 minus 2 times square root of 10 here 7 is 5 plus 2, so we'll substitute 7 by 5 plus 2 minus 2, and we'll substitute square root of 10 by square root of 5 times square root of 2. So we found out that the expression 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. And here we will substitute 5 by square root of 5 square, because of the fact that 5 equals to square root of 5 square. And we'll substitute 2 by square root of 2 square, because of the fact that square root of 2 square indeed equals to 2. Okay, because the square cancels the root and we left only with 2, and here also the square cancels the root and we left only with 5. Okay, minus 2 times square root of 5 times square root of 2. Here we have the expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2. This expression is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. I'll repeat again. This expression is very similar to the expression that a square plus b square minus 2 times ab equals to a minus b square. So according to this algebraic identity, we can substitute our expression by a minus b square, where a equals to square root of 5 and b equals to square root of 2. Okay, so we'll do it now. and we get that our expression, it is actually equals to a minus b squared. So a is square root of 5 minus b. b is square root of 2, all inside the brackets, and we will square it. Again, according to this algebraic identity, a squared plus b squared minus 2 times ab equals to a minus b squared. The expression square root of 5 squared plus square root of 2 squared minus 2 times square root of 5 times square root of 2 equals to square root of 5 minus square root of 2 squared. So in conclusion, we found out that the expression 7 minus 2 times square root of 10 is equal to square root of 5 minus square root of 2 squared. Therefore, we will substitute the expression that is inside the root, that is actually 7 minus 2 times square root of 10, by the expression that is actually equal to 7 to square root of 5 minus square root of 2 square. Because of the fact they are equal to each other, we can do it. And we will get that x equals to square root of 10 minus 1 plus minus, and I will repeat again, we will substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, all divided by 2. So we actually got here that x equals to square root of 10 minus 1 plus minus. Here inside the root we have square root of 5 minus square root of 2 square. So here the square cancels the root, and we left only with square root of 5 minus square root of 2. All divided by 2. So here we will have two solutions that are possible for x. We will define the first solution as x1 and the second solution as x2. So the first solution for the quadratic equation will be x1, and it will be equal to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution of the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. The second solution will be x2, that will be equal to square root of 10 minus 1 minus square root of 5 minus square root of 2, all divided by 2. Okay? So we'll continue with x1. We will develop the expression for x1. So x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. So x1 equals to square root of 10. We will substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 all divided by 2. So here we will take square root of 5 as a common factor, and we will get that square root of 5 is a common factor. For here inside the brackets we will have square root of 2, and here we took square root of 5 as a common factor. So what is left from square root of 5? What is left? It is actually plus 1. And here we have minus 1, minus square root of 2, so we will take minus 1 as a common factor, and inside the brackets, what is left, after we took minus 1 as a common factor, what is left, it is actually square root of 2 plus 1, all divided by 2. So x1 equals to, here we will take square root of 2 plus 1 as a common factor out of this expression, and we will get that square root of 2 plus 1. So what is left from this expression after we took from it square root of 2 plus 1? What is left? It is actually square root of 5. And what is left from this expression after we took from it square root of 2 plus 1 as a common factor? What is left from it? It is actually minus 1 over 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We will do the same process for x2 also. So here we will get that x2 equals to square root of 10 minus 1. Here we have minus before the bracket, so it will be minus square root of 5. Minus and minus is plus, so here we will get plus square root of 2, all divided by 2. So x2 equals to, here square root of 2, we have here square root of 10, so we'll substitute square root of 10 by square root of 5 times square root of 2, minus 1, minus square root of 5 plus square root of 2, all divided by 2. So we got that x2 equals to, here we take square root of 5 as a common factor out of these two expressions, and we get what is left from square root of 5 times square root of 2 after we took from it square root of 5 as a common factor. What is left, it is actually square root of 2, and what is left from minus square root of 5 after we took from it square root of 5 as a common factor, what is left from it is actually minus 1. And we have also here square root of 2 minus 1, all divided by 2. So here we take square root of 2 minus 1 as a common factor out of this expression, and we get that square root of 2 minus 1 is a common factor. What is left from this expression after we took from it square root of 2 minus 1 is a common factor? What is left from it is actually square root of 5. And what is left from minus square root of 2 minus 1 after we took from it square root of 2 minus 1 as a common factor? What is left from it is actually minus 1, all divided by 2. Okay, so we found out that x2 equals to square root of 2 minus 1 times square root of 5 minus 1 over 2. Okay, so here we actually have square root of 5 minus 1. We took square root of 2 minus 1 as a common factor, so inside the brackets we have square root of 5 minus 1. Repeat here again, it is, we have some mistake here. So here we took square root of, this is actually square root of 2 minus 1 plus square root of 2 minus 1. Then we took square root of 2 minus 1 as a common factor, and here we will have square root of 5. So it is actually square root of 5 plus 1. Okay, square root of 5 plus 1. Okay, so we have here two solutions that are possible for the quadratic equation x1 and x2. In the next step, we will multiply x1 by x2 and so first of all I will copy the solutions x1 and x2 in a new page. x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So those are the two solutions for the quadratic equation x1 and x2. So in the next step we will multiply x1 by x2. x1 times x2 will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2 times x2. x2 is square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. So here I will change the order of the expressions in this expression, and we will get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 all divided by 2 plus 2, 2 times 2. So we'll calculate the value of the expression square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. In our specific expression, a is equal to square root of 2 and b equals to 1. So a squared is square root of 2 squared, that is actually 2, minus b squared. B is 1, so b squared is 1 squared. 1 squared is 1, so it is 2. A squared minus b squared, it is minus 1. So the value of the expression square root of 2 plus 1 times square root of 2 minus 1 is 2 minus 1, that is actually equals to 1. In the same way, we will calculate the value of the expression of square root of 5 plus 1 times square root of 5 minus 1 according to the algebraic identity. A plus b times a minus b equals to a squared minus b squared. In our specific expression, a equals to square root of 5 and b equals to 1. So a squared minus b squared So here a squared minus b squared, a squared is square root of 5 squared, it is actually 5, minus b squared, b is 1, so b squared is 1 squared, 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1, that is actually 4. And in conclusion, we actually found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, and 2 times 2 is 4. 1 times 4 is 4, 4 over 4 is 1. So we found out that x1 times x2 equals to 1. I'll repeat again. We actually found out that x1 times x2 equals to 1. What is the meaning of this equation that x1 times x2 equals to 1, it means that x1 is the inverse number of x2, and it is also true to say that x2 is the inverse number of x1. x2 is the inverse number of x1. Okay, but according to equation number 3, we already found out that x times y equals to 1. It also means that x is the inverse number of y and y is the inverse number of x, but if we put the solutions to the equation inside this equation, actually we have two solutions to the equation. The first solution will be x1, y1, and the second solution will be x2, y2. So if we put the first solution of the question inside the question number 3, it means that x equals to x1 and y equals to y1. We will get that x1 times y1 equals to 1. And here, what is the meaning of this equation number 3 that states that x1 times y1 is equal to 1? It means that y1 is the inverse number of x1. Okay, y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. We already found out that x2 is the inverse number of x1. So we have two numbers, that is to say y1 and x2, that both of them are the inverse numbers. Both of them are the inverse number of x1. But according to the rule that x1 has only one inverse number, we will conclude that y1 is equal to x2. Okay? Each number has only one inverse number. x1 has only one inverse number. Therefore, y1 must be equal to x2. And likewise, we have the first solution. The second solution to the question is x2, y2, and equation number 3 says that x times y equals to 1. So if we put the second solution inside the question number 3, we'll get that x2 times y2 equals to 1. So what does this solution mean? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. So we have two numbers, that is to say y2 and x1, that both of them are the inverse number of x2, but x2 can have only one inverse number. Therefore, we will conclude from it that y2 must be equal to x1, and we have already found out that y1 is equal to x2. So now we can answer to the question. The two solutions to the question are as follows. The first solution to the question is x1, y1 of the values of x and y, and x1 is equal to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is x1, y1, according to what we have already found out, y1 equals to x2. So y1 that equals to x2 will be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the first solution to the question, and the second solution to the question is x2, y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2 and y2, according to what we have already found out, that y2 equals to x1. So y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, so x1, y1 is the first solution, and x2, y2 is the second solution to the question. Okay, so those are the two solutions to the question. Now I will summarize the lecture. Actually, we wanted to find out the values of line segments x and y, x equals to FC and y equals to AD, and we have here square DEBF. One side of this square equals to 1 unit, and the square is inside the right triangle, triangle ABC, and the hypotenuse AC of the right triangle, triangle ABC equals to 3 units, and we want to find out the value or the values of x and y. Okay, so first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, DE is parallel to BF, PC is one side of the right triangle, triangle ABC, Therefore, BC is it is absolutely a straight line. BC is a straight line, and we know that part of the straight line BC, that is BF, is parallel to DE. So if part of a straight line is parallel to DE, then the straight line itself BC will be also parallel to DE. Therefore, BC is parallel to DE. Okay? BC is parallel to DE, and then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. Okay, so angle AED is equal to angle ECF according to rule number 1. And if we define angle AED as theta, here angle AED equals to theta, then from this equation, theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta. So this angle ECF equals to theta also. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have side AB. AB is one side of the right triangle ABC. Therefore, it is absolutely a straight line. AB is the side of a triangle. It is absolutely a straight line. AB is a straight line. So if we focus on this side of the straight line AB at point D, then the sum of the angles here must be equal to 180 degrees. So if we define this angle as x, and we get that x plus 90 degrees equals to 180 degrees. X plus 90 degrees equals to 180 degrees according to rule number 2. Here we'll subtract 90 degrees from this equation, and we get that angle x equals to 90 degrees. So this angle is a right angle, it equals to 90 degrees. Then we know that BC is one side of the right triangle ABC. So BC is a side of a triangle. It is absolutely a straight line. BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles here must be equal to 180 degrees. So we define this angle as angle EFC as x, plus this angle is equal to 90 degrees. In total, the sum of those two angles must be equal to 180 degrees. 90 degrees plus x equals to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle x equals to 180 degrees minus 90 degrees is 90 degrees. Okay, so this angle is a right angle, it equals to 90 degrees. Then we focused on the right triangle, triangle ADE. Here, tangent theta equals to AD over DE. In the right triangle, triangle AD. It is actually triangle ADE. In the right triangle, triangle ADE. The triangle is triangle ADE. Here, tangent theta equals to AD over DE. AD equals to y, DE equals to 1. So in conclusion, we found out that tangent theta equals to y. Then we focus on the right triangle, triangle EFC. Here, tangent theta equals to EF over FC. In triangle EFC, tangent theta equals to EF over FC. EF equals to 1, FC equals to X. Therefore, in conclusion, we found out that tangent theta equals to 1 over X. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 2, that is actually y over x. So according to equation number 3, we got that y equals to 1 over x. Here we multiply the equation number 3 by x, and we got that y times x equals to 1. And whenever the multiplication of two numbers is equal to 1, it means that x is the inverse number of y, and y is the inverse number of x. Okay, and we have the rule that each number has only one inverse number. Then we focused on the right triangle, triangle ABC. Here, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, and the square of the hypotenuse is AC square. AC square equals to AB square plus BC square. Again, according to equation number 4, AC square equals to AB square plus BC square. And AC equals to 3, so AC square is 3 square. 3 square is 9. AB equals to y plus 1. So AB square is y plus 1 square. BC equals to x plus 1. So BC square is x plus 1 square. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here we open the brackets in this side of equation number 4, and we got that y plus 1 square is y square plus 2y plus 1, plus x plus 1 square is x square plus 2x plus 1, and it equals to 9. And then we have equation number 3 that states that y equals to 1 over x. That is to say, we can substitute y in equation number 4 by 1 over x. We did it, and we got that y square will be equal to 1 over x square, plus 2y is 2 times 1 over x, plus 1, plus x square plus 2x, plus 1 equals to 9. Then we organize the equation number 4 in a different way, and we got that x squared plus 1 over x plus 2 plus 2x plus 2 over x equals to 9. The expression that is inside the brackets is equal to x plus 1 over x squared plus 2 times, here we took 2 as a common factor out of these two expressions, and inside the brackets, from this expression we have x, and from this expression we have 1 over x. So equation number 4 says that x plus 1 over x squared plus 2 times x plus 1 over x equals to 9. Then we defined t as x plus 1 over x, that is to say t equals to x plus 1 over x. So now we can substitute x plus 1 over x by t. We did it, and we got that here, this is actually x plus 1 over x squared is t squared, plus 2 times x plus 1 over x is 2t, and it equals to 9. We subtracted 9 from this equation, and we got the t squared plus 2t minus 9 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c in this general formula are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, t squared plus 2t minus 9 equals to 0. Here, the variable that we're looking for is t, so x equals to t, and the coefficients of this quadratic equation are as follows: a equals to 1, t equals to 2, and c equals to minus 9. So we put the data inside the equation for x, and we found out that t equals to here minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 4, minus 4 times ac is c is minus 9, so minus 4 times ac is plus 36, all divided by 2. So t equals to minus 2 plus minus 4 plus 36 is 40 over 2. But 40 is 4 times 10. The square root of 4 is 2. So in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here, minus 2 over 2 is minus 1, plus minus 2 over 2 is 1. So in conclusion, we found out that t equals to minus 1 plus minus square root of 10. So here we have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10. We focused on the second solution. So according to our definition, t equals to x plus 1 over x, and x plus 1 over x equals to minus 1 minus square root of 10. But because of the fact that x is a length, s is the length of the one side of the right triangle, triangle AFC, therefore it must be a positive number. 1 over x also must be a positive number, and x plus 1 over x must be a positive number. But according to the solution that we got, we have here an equation that says that a positive number is equals to minus 1 minus square root of 10, that is a negative number. So we have here a contradiction, because a positive number can never be equal to a positive number can never be equal to a negative number. Therefore, this solution is incorrect solution. We cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. T, according to our definition, is x plus 1 over x, and it equals to minus 1 plus root of 10. Here we multiplied x by x, and then we divide it by x in order to have a common factor with 1 over x. And we got that x squared plus 1 over x equals to minus 1 plus square root of 10. We multiplied this equation by x, and we got that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtracted square root of 10 minus 1 times x from this equation, and we got the quadratic equation that says that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general formula for the solution of a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And so we will put the data inside this equation in order to find out the value of the values of x. We actually found two solutions for x, x1 and x2. So here we got that x equals to b is square root of minus square root of 10 minus 1, and minus minus is plus. So in conclusion, we found out that minus b equals to square root of 10 minus 1 plus minus b squared minus 4 times ac. B is square root of 10 minus 1, so b squared is square root of 10 minus 1 square. Minus 4 times AC is minus 4. And square root of 10 minus 1 square, it equals to 10 plus 1 minus 2 times square root of 10. And here we have also minus 4. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus 10 plus 1 minus 2 times square root of 10 minus 4. 10 plus 1 is 11, 11 minus 4 is 7. So in conclusion, we found out that x equals to square root of 10 plus 1 plus minus square root of 7 minus 2 times square root of 10 over 2. Okay, then we actually treated the expression. We changed the expression that is inside the root, that is actually 7 minus 2 times square root of 10. We substituted 7 by 5 plus 2, and here we have minus 2 times, and we substituted square root of 10 by square root of 5 times square root of 2, and 5, we substituted 5 by square root of 5 square, and we substituted 2 by square root of 2 square. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 plus square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2. But this expression is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. Okay? Therefore, according to this algebraic identity, we can substitute our expression by a minus b square. When here a equals to square root of 5, b equals to square root of 2. So a minus b square equals to square root of 5 minus square root of 2 square. And we actually found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. So we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. We did it, and we got that x equals to square root of 10 minus 1 plus minus. So we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, all divided by 2. So here x equals to square root of 10 minus 1 plus minus. Here we have inside the root square root of 5 minus square root of 2 square and root. The root cancels the square, and we left only with square root of 5 minus square root of 2. So in conclusion, we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So here we will have two solutions that are possible for x, x1 and x2. The first solution is x1 and the second solution is x2. The first solution, x1, is square root of 10 minus 1 plus square root of 5 minus 2 over 2. And the second solution for x is x2. That is actually square root of 10 minus 1 minus square root of 5 minus 2 over 2. We continued with the first solution, x1. Here we open the brackets, and we got that x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. Here we substitute square root of 10 by square root of 5 times square root of 2, and we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and we got that x1 equals to square root of 5 is a common factor. So inside the brackets, from this expression we have square root of 2, and from this expression what is left is actually 1. So in conclusion, we found out that x1 equals to square root of 5 times square root of 2 plus 1 minus square root of 2 plus 1 over 2. Here we took square root of 2 plus 1 as a common factor, and we got that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the first solution, and we did the same process on the second solution x2, we actually developed the expression. Here we open the brackets, so we will get here, it will be minus 5 squared and minus is plus, so here it will be plus 2, plus square root of 2. So in conclusion we got that x2 equals to square root of 10 minus 1 times square root of 10 minus 1 minus square root of 5 plus square root of 2 over 2. Here we substituted square root of 2 by square root of 5 times square root of 10, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. So here we took square root of 5 as a common factor out of those two expressions, and we got that square root of 5. From this expression, what is left is square root of 2, and from this expression, what is left after we took square root of 5 as a common factor, what is left, it is actually minus 1 plus square root of 2 minus 1 over 2. Here we took square root of 2 minus 1 as a common factor, and we got that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So we got the solutions x1 and x2 for our quadratic equation. Then I copied the solutions x1 and x2 in this new page, and we multiplied x1 by x2, and we got that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 2 times 2. Here we solved, we got to the value of this expression square root of 2 plus 1 times square root of 2 minus 1, according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. In the number specific expression, a equals to square root of 2 and b equals to 1. So a squared is square root of 2 squared, that is actually 2, and b squared, b is 1, so b squared is 1 squared is 1. So a squared minus b squared is 2 minus 1. This is the value of this expression. And then we calculated the value of square root of 5 plus 1 times square root of 5 minus 1, according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a equals to square root of 5. So a squared is square root of 5 squared, square root of 5 squared is 5, minus b squared. B is 1, so minus b squared is minus 1 squared, that is 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. And in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, and 2 times 2 is 4, so, and 4 times 1 is 4, and 4 over 4 is 1. So in conclusion, we found out that x1 times x2 equals to 1. Again, we actually found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2, and x2 is the inverse number of x1. But we have also equation number 3. Equation number 3 states that x times y equals to 1, and we have two solutions that are possible to our question. The first solution is the values of x and y is x1, y1, and the second solution is x2, y2. We put the first solution inside equation number 3, and we got that x equals to x1 and y equals to y1, so we got that x1 times y times y1 equals to 1. What does this solution mean? It means that y1 is the inverse number of x1. But we already found out that x2 is the inverse number of x1. So we have two numbers, that is to say y1 and x2, that are the inverse number of the same number, that is x1. And because of the fact that every number has only one inverse number, and therefore y1 must be equal to x2. Otherwise, x1 will have more than one inverse number. Okay, therefore y1 must be equal to x2. Likewise, we put the second solution to the question that is actually x2, y2 inside equation number 3. So here x equals to x2 and y equals to y2. And we will get that x2 times y2 equals to 1. What does equation number 3 means? It means that y2 is the inverse number of x2. y2 is the inverse number of x2, but we have already found out that x1 is the inverse number of x2. So we have two numbers, y2 and x1, that are the inverse number of the same number x2. And according to the rule that each number has only one inverse number, therefore y2 must be equal to x1. Otherwise, x2 will have more than one inverse number. Therefore, we must include that y2 equals to x1. In order that x2 will have only one inverse number, y2 must be equal to x1. So in conclusion, we got that y2 equals to x1 and y1 equals to x2. And the solution to the question, we have two solutions to the question. The first solution is x1, y1. x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And x2, we have already found out that, and y1, we have already found out that y1 equals to x2. So y1 that equals to x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2, y2. x2 equals to square root of 2 minus 1 times square root of 5 minus 1 over 2. And y2 equals to x1. y2 equals to x1. So y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So those are the two solutions to the question, x1, y1 and x2, y2. Okay, thank you very much.